The job presented several challenges. Firstly, there was a lack of an electrical box for the fan. Secondly, the BX cable had no ground wire. And thirdly, the neutral wire was incorrectly wired, also known as a switch neutral. To address the lack of an electrical box, the solution is to install an electrical box. This is necessary to meet code requirements for supporting the fan and providing a grounding point. When dealing with BX cable that has no ground wire, a separate ground wire needs to be run from the electrical box to the fan. This can be accomplished using a wire mold or another acceptable method to ensure proper grounding. To correct the switch neutral, careful identification of the incorrect wiring is essential, followed by rewiring the neutral and hot wires correctly. In this scenario, there was additional work because the owner had 2 more fans that needed to be brought up to code. This involved identifying and correcting the switch neutral wiring in those fans as well. Furthermore, it's crucial to inspect and verify the electrical safety of the entire house. The switch neutral issue may indicate other potential electrical hazards that need to be addressed to ensure the safety of the occupants. The job took longer than expected due to the additional steps required to address the electrical code violations. Identifying and resolving electrical issues is crucial for safety. Neglecting these issues could lead to potential hazards. When installing an electrical box, several factors should be considered. The box must be sized appropriately for the number of conductors it will contain. National Electrical Code, or NEC, Section 314.16 provides guidance on calculating box fill. The box should be securely mounted to a structural member to support the weight of the fan. The NEC specifies requirements for box mounting in Section 314.23. When running a separate ground wire, it should be sized according to the overcurrent protection device in this circuit. NEC Table 250.122 provides the minimum size of equipment grounding conductors. The ground wire should be connected to a grounding terminal in the electrical box and to the fan's grounding terminal. When identifying and correcting a switch neutral, a multimeter is essential for verifying the correct wiring. The hot wire should be connected to the switch, and the neutral wire should be connected to the neutral terminal in the electrical box. If the neutral wire is connected to the switch, it indicates a switch neutral. When inspecting the electrical safety of the entire house, look for other potential hazards such as overloaded circuits, damaged wiring, and improperly grounded outlets. An infrared camera can be helpful for identifying hotspots in the electrical system, which may indicate overloaded circuits or loose connections. When working with electrical systems, always prioritize safety. To energize the circuit before working on any electrical components. Use appropriate personal protective equipment such as insulated gloves and safety glasses. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician. Some common electrical code violations to look out for include improperly sized conductors, overcurrent protection devices that are too large, and missing or damaged grounding conductors. NEC Article 210 covers branch circuits, including conductor sizing and overcurrent protection requirements. NEC Article 250 covers grounding and bonding requirements. When replacing an existing fan, it is important to ensure that the new fan is compatible with the existing electrical system. Check the voltage and amperage requirements of the new fan and compare them to the existing circuit. Ensure that the fan is properly rated for the location where it will be installed. For example, a fan installed in a damp or wet location must be rated for that environment. When working with BX cable, it is important to ensure that the cable is properly supported and protected from physical damage. NEC Section 330.30 provides requirements for securing and supporting BX cable. If the BX cable is damaged, it should be replaced. When making connections to BX cable, use appropriate connectors that are listed for use with BX cable. When troubleshooting electrical problems, it is important to have a systematic approach. Start by identifying the symptoms of the problem and then use a multimeter to test the circuit for voltage, continuity, and resistance. Consult the NEC and other relevant resources to determine the cause of the problem and the appropriate solution. Always double-check your work to ensure that the electrical system is safe and functioning properly. Consider the specific requirements for electrical boxes in various applications. For example, when installing an electrical box in a fire-rated wall, it must be a fire-rated box. When installing an electrical box in a wet location, it must be a weatherproof box. NEC Section 314.40 covers the requirements for boxes in different locations. When running a ground wire, it should be run in a manner that protects it from physical damage. The ground wire should be securely fastened to the electrical box and to the fan. The ground wire should not be spliced or damaged in any way. When correcting a switch neutral, it is important to verify that the correct wires are connected to the correct terminals. Use a multimeter to test the voltage between the hot wire and the neutral wire. The voltage should be approximately 120 volts. If the voltage is not correct, it indicates a switch neutral. When inspecting the electrical safety of the entire house, pay close attention to the condition of the wiring. Look for signs of damage, such as cracks, cuts, or abrasions. If the wiring is damaged, it should be replaced. Also, check the condition of the outlets and switches. If they are loose or damaged, they should be replaced. Consider the use of arc fault circuit interrupters, or SIs, to protect against electrical fires. SIs are designed to detect arc faults, which are a common cause of electrical fires. SIs can be installed in place of standard circuit breakers in the electrical panel. NEC Section 210.12 requires SIs in certain locations. When working with electrical systems, always be aware of the potential hazards. Electricity can be dangerous if not handled properly. Take your time and follow all safety precautions. If you are unsure about any aspect of the electrical work, consult with a qualified electrician. Consider the use of ground fault circuit interrupters, or GFCIs, to protect against electric shock. GFCIs are designed to detect ground faults, which can cause electric shock. GFCIs should be installed in locations where there is a risk of electric shock, such as bathrooms, kitchens, and outdoor areas. NEC Section 210.8 requires GFCIs in certain locations. When installing a new fan, it is important to ensure that the fan is properly balanced. An unbalanced fan can cause excessive vibration and noise. Follow the manufacturer's instructions for balancing the fan. When working with electrical systems, it is important to have a good understanding of the NEC. The NEC is a comprehensive set of standards for electrical installations. The NEC is updated every 3 years. You can purchase a copy of the NEC from the National Fire Protection Association, or NFPA. Consider the use of surge protectors to protect electronic equipment from power surges. Surge protectors can be installed at the electrical panel or at individual outlets. Surge protectors can help to prevent damage to electronic equipment from lightning strikes and other power surges. When working with electrical systems, it is important to keep the work area clean and organized. This will help to prevent accidents and make it easier to find the tools and materials that you need. Consider the use of a voltage tester to verify that a circuit is de-energized before working on it. A voltage tester is a simple and inexpensive tool that can save your life. Always use a voltage tester to verify that a circuit is de-energized before touching any wires or components. When working with electrical systems, it is important to be aware of the local electrical codes. Local electrical codes may be more stringent than the NEC. Check with your local building department to determine the applicable electrical codes. Consider the use of a wire stripper to remove insulation from wires. A wire stripper is a specialized tool that is designed to remove insulation without damaging the wire. Always use a wire stripper to remove insulation from wires. When working with electrical systems, it is important to use the correct type of wire for the application. Different types of wire are designed for different purposes. Using the wrong type of wire can be dangerous. Consult the NEC or a qualified electrician to determine the correct type of wire to use. Consider the use of a fish tape to pull wires through conduit. A fish tape is a flexible tool that can be used to pull wires through tight spaces. Always use a fish tape to pull wires through conduit. When working with electrical systems, it is important to be aware of the dangers of working with electricity. Electricity can be dangerous if not handled properly. Take your time and follow all safety precautions. If you are unsure about any aspect of the electrical work, consult with a qualified electrician. Maintaining up-to-date knowledge of electrical codes is essential. The NEC is revised every 3 years, so staying current with the latest edition is crucial for safe and compliant electrical work. Local jurisdictions may also have their own amendments or additions to the NEC, so it's important to be aware of those as well. Continuous education and training are vital for electricians to stay proficient and knowledgeable in their field. Proper planning and preparation are key to a successful electrical job. Before starting any work, thoroughly assess the situation, identify potential hazards, and gather all necessary tools and materials. This will help to minimize delays and ensure a safe and efficient work process. Using the right tools for the job is essential for both safety and efficiency. Invest in quality tools that are specifically designed for electrical work. Make sure your tools are properly maintained and in good working condition. Proper grounding is a critical safety measure in electrical systems. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. Make sure all electrical boxes, equipment, and appliances are properly grounded. Bonding is the process of connecting all metal parts of an electrical system together to create a low impedance path for fault current. Bonding helps to ensure that all metal parts are at the same potential, which reduces the risk of electrical shock. Make sure all metal parts of the electrical system are properly bonded. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Make sure the overcurrent protection devices are properly sized for the circuit they are protecting. Using the wrong size overcurrent protection device can be dangerous. Electrical connections should be made with care and precision. Loose or corroded connections can cause overheating, arcing, and even fires. Make sure all electrical connections are tight and secure. Wire connectors should be used to join wires together. Wire connectors are designed to provide a secure and reliable connection. Make sure the wire connectors are properly sized for the wires they are connecting. Electrical tape should be used to insulate electrical connections. Electrical tape helps to prevent short circuits and electrical shock. Make sure the electrical tape is properly applied and that it covers all exposed conductors. Electrical conduit is used to protect electrical wires from physical damage. Conduit can be made of metal or plastic. Make sure the conduit is properly installed and that it is securely supported. Electrical boxes should be used to enclose electrical connections. Electrical boxes provide a safe and secure enclosure for electrical connections. Make sure the electrical boxes are properly sized and that they are securely mounted. When working with electrical systems, it is important to be aware of the potential for arc flash. Arc flash is a dangerous electrical explosion that can cause serious burns and other injuries. Wear appropriate personal protective equipment, such as arc-rated clothing, when working on energized electrical equipment. Lockout/tagout procedure should be used to energize electrical equipment before working on it. Lockout/tagout procedures help to prevent accidental energization of electrical equipment, which can cause serious injuries. Always follow lockout/tagout procedures when working on electrical equipment. Regular electrical inspections are important to ensure the safety of an electrical system. Electrical inspections can identify potential hazards and ensure that the electrical system is in compliance with electrical codes. Schedule regular electrical inspections with a qualified electrician. When working with electricity, always remember to stay safe and take your time. Electricity can be dangerous if not handled properly. If you are unsure about any aspect of the electrical work, consult with a qualified electrician.